made out of the same material, a central iron core and a rocky mantle. Unfortunately, the comparisons end there. Unlike Earth, Venus is extremely hot, has an incredibly dense atmosphere, and toxic fumes on its surface. What would we need to do to make it habitable? Scientists and astronomers have been theorizing how to terraform Venus for over half a century. The two biggest issues that need to be solved are the atmosphere and the temperature on Venus. Currently, the surface of Venus is a sweltering 462 degrees, hot enough to melt lead. And the atmosphere, made up mostly of carbon dioxide, is 93 times as heavy as Earth's. One proposed way of altering Venus's atmosphere is to bomb it with hydrogen. Hydrogen bombs, when reacting with the carbon dioxide in the atmosphere, would create graphite and water. This would fall down to the planet's surface and cover 80% of it with oceans. Mind you, they wouldn't be nearly as deep as Earth's oceans. Venus would only have 10% the amount of water that Earth has. This would take a lot of hydrogen. The only way we could get enough is if we were to harvest the resource from Jupiter or Saturn. This approach would also require iron aerosol, a material that can be mined from asteroids. If all went according to plan, the dense carbon dioxide atmosphere would be reduced to being just 3 times as heavy as Earth's. Okay, that's manageable. This would also help clear the clouds of sulfuric acid that hang over the planet. Okay, the atmosphere's clear. Now, what about the temperature? One way to cool the surface is with solar shades, a series of small spaceships or one large lens that would divert the rays of the sun. These solar shades could be placed on the surface of the planet or in the atmosphere, slowly working to cool down the planet and reduce radiation, another issue that would need to be resolved before we started living on Venus. In addition to solar shades, NASA thinks that we could build floating cities above the clouds of Venus. These would work as a safe living space as we learn and attempt to terraform the environment. To cool the planet even more and to speed up the process, cooling pipes could be put on the surface of the planet. These pipes would take heat from the surface and bring it up to colder parts of the atmosphere. Now we have a suitable atmosphere, a proper temperature, and clean air. But there's one other huge issue that humans might have if they move to Venus. They'd have extremely long days and nights, since Venus rotates once every 243 Earth days, meaning a day on Venus is 5,800 hours long. Not to mention, it's the only planet in our solar system to rotate clockwise, meaning that its extremely slow sunrise would happen in the west, and sunsets would be in the east. We could create the illusion of a 24-hour day cycle by using massive mirrors and having them rotate to reflect the sun. If this managed to work correctly, Venus would feel just like home, with maybe a touch less gravity. After all this, Venus would finally be habitable. Sure, the planet would rotate differently and you'd get a different view of the sun, but it could be another place for humans to live. Scientists theorize that it could be a backup planet one day. Studying more about Venus could teach us something about Earth. Venus suffers incredibly strong greenhouse effects, the cause of its extreme temperatures and dense atmosphere. By learning more about cooling this planet, it may unlock the secrets to cooling our own and maybe make our home last even longer. Okay, let's say we're ready to move to a terraformed Venus. Well, let me ask you, how in Mars's atmosphere, it still wouldn't be nearly enough to heat the planet, and the planet could seriously use more heat, since its current temperature averages around -63 degrees. And it would take decades for the red planet to warm up, even after it gained the extra CO2. So, in theory, this could delay humans from ever landing on Mars. Not only that, but this assumes that dropping thermonuclear bombs on the planet would go perfectly. Keep in mind, these are nukes. You know, the things that can destroy entire cities. In fact, the bombs we'd use on Mars would be 1,000 times stronger than the ones used in World War II. If a bomb exploded on the planet's surface instead of up in the atmosphere, some severe damage would occur. Not only would it completely destroy parts of the planet's surface, it would also cause even more radiation, another thing that would delay us from ever settling on Mars. It's also very likely that instead of warming Mars, a bomb could cause a nuclear winter. This could happen from the dust and particles in the atmosphere caused by nuclear explosions. They'd almost entirely block out the sun, causing Mars to cool down even more. So, nuking Mars probably isn't the best idea. And maybe we should get some humans on the planet in its natural state before we start trying to change it.
Okay, we've talked about settling on the moon, on Mars, and even Venus, but how about somewhere that's cold, dark, and here's what would happen if you lived on Uranus. Welcome to your new home on the 7th planet from the Sun. You'd now be a whopping 2.9 billion kilometers away from our solar system's energy source. Following in the footsteps of NASA's Voyager 2 probe, the journey to Uranus would take about 9.5 years, but now that you've made it, you'd catch a great view of this ice giant. What you'd find is a planet 4 times wider than the Earth, orbited by 27 known moons and 13 rings. Plus, it would be rotating east to west and tipped on its side. Well, it's about time you head down to the surface. When it's surface, you'd start to notice there isn't one. Uranus is smaller and compositionally different than the gas giants Jupiter and Saturn. It consists of slushy water, methane, and ammonia fluids above a small rocky center. Not that you'd be able to see very much. Uranus only receives about 0.27% as much sunlight as the Earth. So you'd be living in darkness. With the lack of sunlight and surface, you couldn't grow your own food there. Your ship would need to supply you with food. But you could source your water from the planet's water ice. You'd find conditions on the planet very cold and windy. Temperatures in some parts of the atmosphere could be as low as minus 225 degrees. That's colder than Neptune, the outermost planet in the solar system. Massive clouds of ammonia and methane ice crystals would swirl around you. Storms, almost 2/3 the size of the United States, would batter you with wind speeds up to 900 kilometers per hour. But it's too late to turn back now. You'd need to learn how to settle and survive in these conditions. Establishing yourself on the surface would be a definite no-go. And the strongest, most frigid winds would tear you apart in the lower altitudes. Your best bet would be a floating settlement up high in the clouds. But this wouldn't be your average blimp or airship settlement. Blimps only lift when inflated with a gas that's lighter than the surrounding atmosphere. On Earth, you'd use helium. On Uranus, there wouldn't be any lighter gas to use. That's due to the atmosphere made of molecular hydrogen and atomic helium. However, you could try something more theoretical, like a near vacuum ship. Instead of gas, this kind of ship would create a vacuum to lift. You'd simply remove gas or add it to allow the ship to go higher or lower. And it would be a clean technology. No fuel needed. You should get comfy because you'd never be able to leave your ship without your spacesuit. On Uranus, you couldn't breathe. And you couldn't survive a second in the unbelievably frigid temperatures. Just stay safe and enjoy the view. Okay, now that you've figured out how to survive, what would life on Uranus be like? Well, for starters, you'd find a slightly different sense of gravity than you're used to. But considering that Uranus is 15 times more massive than Earth, you'd be surprised by the difference. Contrary to what you might think, you wouldn't have to worry about being crushed. The surface gravity would be only 90% as strong as the Earth's. So if you weighed 75 kilograms on Earth, you'd now be a lighter 67 kilograms. Another thing you'd have to get used to is time. One Uranian day would be equal to about 17 hours on Earth. That wouldn't be so bad, but get ready for one incredibly long trip around the Sun. 1 year on Uranus would equal 84 Earth years. Yeah, you could die of old age before the year is over. You could even live an entire life in just one 42-year-long summer or winter.
It's one of humanity's most ambitious undertakings, created to extend human exploration to the farthest reaches of our solar system.
The next step in space exploration isn't generations away. It's happening right now. And our destination? That mysterious and desolate world next door, Mars. Imagine starting life over on that tiny red dot, over 265 million kilometers away. What would happen if we built a city on Mars?